In this lecture, we're going to learn about function objects or functors in C++. And a functor is basically a class object that you can call like a regular function. And we set up functors or function objects by setting up a class in C++ and by overloading the function call operator or the parent operator, as some people like to call it. Let's look at a simple example. We have seen a function pointer to encrypt character data. We can wrap that function into a functor or a function object whose job is really to encrypt character text. We set that up by setting up a class. So this is a regular class. We can give it any name we want. In this case, we're going to call it encrypt. And we're going to overload the function call operator. You have the flexibility to return whatever you want or pass in any parameter you want. The only requirement is that you call it operator and say parent as we do here. And this is going to set up our class as a functor. So if we have an object of this encrypt class, we can do a function call operator and get this function here called and do all kinds of crazy things. Now, some of you must be asking, why go through this trouble? Well, this is going to make it easier to work with function pointers and callbacks as we are about to see in the next few lectures. But in this lecture, we just want to understand the mechanics of how a function object works in C++. And this is how you set it up. Once you have it set up, you can really use it like you use a function pointer. You can create an object of our encrypt function object or functor. We can also set up another one to decrypt as we are about to see in Visual Studio Code. And you can use these function objects to do stuff. For example, we can call it like we call a simple function by adding a parent and putting in our parameter. And this is going to do whatever we were doing in our function call operator here. So for example, in our encrypt functor, if we call it like we do here, this is going to encrypt A and return whatever is the result of that encryption. That's going to be D. If we decrypt D, we will get an A out because decrypting A using the mechanism we have seen before, that's going to move backwards by 3 characters in the alphabet, and we will get an A printed out right here. So this is really how you use functors or function objects in C++. One other thing you can do with these guys is that you can use them as callbacks. And to do that, we will set up a function that is really going to take any kind of callback in. We want the flexibility to either use function pointers or function objects. And we will achieve this by templating on the callback type that we pass here. So we're going to say template type name modifier, and modifier is going to be our callback. But the callback can either be a function pointer or a functor, as we are seeing in this lecture here. So if we pass a function pointer, that's going to create an instance for this function template using a function pointer as a callback. If we pass in a functor, C++ compilers are going to create a function template instance using a functor as our callback here, and we have this flexibility. This is going to be modifying data in a string as we have seen before, and we will be calling our modifier function or callback regardless of the type of the callback that we passed in here. If it is a function pointer, we will be calling a function pointer here. If it is a functor, we will be calling our operator function call on our functor, and everything is going to fall in place. We really have this flexibility here. So once we have this function set up, we can do something like this. We can set up a string, which is really going to contain anything. We can put in hello world or whatever, and we're going to modify and decrypt. We're going to see our modified string printed out here. We're going to decrypt it and bring it back to its initial data that we had, and we're going to see this printed out here. Notice that this is going to be using function pointers because our function now is templated. And in this case, we will create a function template instance that passes in encrypt and decrypt as our callbacks, which happen to be function pointers. But we can also use functors, and this is also going to work. So we can pass in our encrypt functor as a callback and our decrypt functor as a callback, and everything is going to really work as we expect. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Functors. We're going to grab our template files and use them as a starting point, so we can put them in place here. I am also going to put in my files to encrypt and decrypt. These are going to be C++ classes, so I am going to put them in here. If you want to, you can grab them from the resource section attached to this lecture, or you can type along because we're going to see what is inside when we open this in Visual Studio Code in a minute. So let's open this up. This is going to give us our project ready for use. We have a decrypt file, which is going to be containing our decrypting functor or function object. And it is a functor because we are overloading the function call operator, which is this parent thing here. So we have a return type, which is char. It is going to take a const character by reference n. And we are going to do whatever we need to do in this operator. In this case, we are decrypting by subtracting 3 to whatever character that was passed to us. And then we are going to return this as a character for this to work as we want. If we go in the CPP file, we're not going to have anything in there because we don't need to do anything. And we can really use this however we want. We also have an encrypt functor. Again, it is going to set up the function call operator. It is going to be encrypting. So in the body, we are going to add a 3 and return whatever we get as a character here. We can hop over in the main function and use our functors. So let's clean up a little bit. And we are going to include encrypt. And we are also going to include decrypt. We can set up our callbacks as regular functions as we have done before, and we can use these guys when we call a function that needs the callback to encrypt or decrypt. What we are going to do is set up a modify function, which is going to be modifying the string that we pass in, and it is going to modify that using a callback that we pass as a second parameter here. Our callback happens to be modifier here. We are using a function template here because we want the flexibility to either pass a function pointer callback or a functor callback, and the compiler is going to instantiate whatever it needs to instantiate depending on what we call our modify function here with. So for example, we can go in our main function here and set up an std string containing hello as the text, and we can encrypt this using our encrypt function pointer. Again, this is a function pointer that we are passing in here, and the compiler is going to see that we are passing in a function, and it is going to create an instance of this function template that takes a function pointer in. So the compiler is going to use that function template instance and pass in the decrypt function pointer here, and everything is going to fall in place. This is everything we have seen before. We can build this using our favorite compiler. The build is going to be good, so we can bring up a terminal window and try to run this. And if we run Rooster, we're going to see that the initial data is hello. We're going to encrypt that to get cool, and we're going to decrypt that and get our hello back. This is what we have in our program here. But I want to bring to your attention that we can also use functors to achieve the same thing. But before we do that, we can play with our functors a little bit. So let's put in a simple separator to separate things out. And we are going to create a bunch of function objects here. We're going to create one for encrypt and one for decrypt. We will use encrypt to encrypt A, and this is going to give us a D printed out. We're going to set up another one to decrypt D, and this is going to give us an A. This is just a simple example to play with this. You can play with this and really see what you get. We can pass this through our compiler to see if this actually works. The build is going to be good, so we're going to clear and run Rooster. And this is going to give us D and A as we expect on these two lines here, 42 and 43. And our functors are really working. So when we do something like this, the compiler is going to call the function call operator in these objects. And that's going to call these guys that we set up here, this operator, parent, and this is going to decrypt if we call this on the decrypt object. And this is going to encrypt if we call this on an encrypting object. And that's what we have in our main CPP file here. So now that we know that our functor can really work, we can use this to do whatever we were doing here using function pointers. So let's go down and set up a simple separator. And we can go down and modify our data using functors that we have on top here. So we're going to call the modify function, and in this case, we are going to pass in a functor And because modify is the function template, the compiler is going to generate a template instance that works on a functor, and the type of the functor is going to be encrypt. Down here, we are going to create another instance that takes in the decrypt functor as the second parameter here, and everything is going to work. Let's try and pass this through our GCC compiler. The build is going to be good, so we can clear and run Rooster. If we go down, we will see that we are going through functors and we will get the data hello. We are going to encrypt that and get core, and we are going to decrypt this and get our hello back. And this is what we have. And this is really all I had to share in this lecture. The basic mechanics that functors use to work. You set up a functor by overloading the function call operator, and you have the flexibility to set up the return type and the input parameters to suit your needs. We are going to stop here in this lecture. In the next one, we are going to learn about some standard functors or function objects we have built into the C++ standard library. Go ahead and finish up here and meet me there.